Okay, so guys, in today's class, we are going to discuss OSI model and we are going to discuss OSI model practically. Okay, theoretically, we already completed the OSI model and today I am going to show you OSI model practically. Okay, fine. Now, if I am not wrong, I already discussed what is packet encapsulation and what is packet decapsulation in OSI model, right? How actually on every layer packet is going to encapsulate and how packet is going to decapsulate at the receiver end. Yes, everyone, tell me guys, yes or no? Yes.
Yes,
For
sir.
example, this is the router 1, this is the router 2. Both router I connect like this. Fine. This is the R1 and this is the R2. For example, on R1 and R2, I'm using any protocol. Any protocol means layer 7 protocol. For example, I'm using here BGP. BGP is a layer number 7 protocol. Fine, everyone. Now tell me one thing. When we configure the BGP on R1, what R1 will do? R1 will generate one BGP packet. Yes or no? Everyone, tell me guys. Router
Yes, sir.
number will generate one BGP packet. At which layer guys? Layer number 7. Fine, everyone. Is this clear to all of you? Tell me guys. Yes?
Yes, sir.
Okay. Now, focus here like this. R1 generate at layer number 7. There will be a one packet that is called which packet guys? BGP packet. Fine. Tell me guys, clear? Okay. That is on layer number 7. What layer number 7 will do guys? Layer number 7 will hand over this packet to layer number 4. Yes or no? Right?
Yes,
Everyone.
sir.
Okay. So come at layer number 4. At layer number 4, what will happen? I told you there are two types of protocol at layer number 4. There is one that is called TCP and second one is called UDP.
UDP.
Right? And please remember one thing, BGP use the TCP. What? BGP use the TCP protocol. Fine. So layer number 4 receive BGP packet from layer number 7. Now what layer number 4 will do? Layer number 4 will add which header guys? TCP header. Yes or no? Right? Layer number 4 will
Yes, sir.
add the TCP header here. Fine. So that it will happen on layer number 4. Clear now? Everyone, tell me guys, yes or no? Yes. So that is on layer number 4. And on layer number 4, the complete data is known as segment.
Segment.
Right? That is called segment. Now, what layer number 4 will do? Layer number 4 will hand over this packet to layer number 3. Yes, everyone. So layer number 3, at layer number 3, there will be a which header guys? First of all, tell me one
IP
thing.
header.
Number 3 receive what? Segment. Right? Layer number 3 receive segment. Yes or no? Yes.
Yes, sir.
Layer number 3 will receive the segment from layer number 4. Fine. What layer number 3 will do? Layer number 3 will add the IPv4 header here. Yes or no? Yes.
Yes, sir.
Layer number 3 will add the IPv4 header. So that is the layer number 3. And layer number 3, that complete data is known as what? Packet.
Sir, recording?
Yes, recording in progress.
Okay.
Now, what layer number 3 will do, guys? Layer number 3 will hand over this packet to layer number 2. Yes? Layer number 3 will hand over this packet to layer number 2. Yes or no? At layer number
Yes,
2,
sir.
layer number 2 receive what? Packet from layer number 3. Yes? Now, layer number 2 will add which header, guys? Ethernet header. Yes or no? Right?
Yes, sir.
Layer number 2 will add the Ethernet header here. Fine. And the complete data is known as what? Frame.
Segment.
No, frame.
Segment.
It is called frame, guys. At layer number 2. Now, that is all about the layer number 2. What layer number 2 will do, guys? Layer number 2 will hand over this packet to which layer? Layer number 1. Right now, everyone. And what layer number 1 will do? Layer number 1 convert this frame into bits. Yes or no? Everyone, tell me guys.
Yes, sir.
Okay. So this is the thing actually happen. Clear? Everyone, yes or no? Right? Now come to the point. I already told you when this packet, BCP packet will move at layer number 4 will add what guys? TCP header. Yes or no? Right? In TCP header, if you guys remember, I told you already some points. What are the things in TCP header generally we get? Who can tell me? TCP header.
Port number.
Yes, first one is guys, source port number, then destination port number. Yes or no?
Port number.
Then guys,
Yes.
sequence number. Then guys, acknowledgement number. Because I already told you, TCP is the reliable protocol. Yes or no? Right, na?
Yes, sir.
TCP is the reliable protocol because in case of TCP, you guys will get acknowledgement for every messages. Yes or no? Right, na?
Yes,
Then
sir.
you will get guys reserved bit. Now tell me next one, guys. If you guys remember, I told you there are some flags also, right? Everyone, tell me, right, na? If you guys remember, I told you there will be a checksum, right? Everyone, tell me yes or no. So generally, guys, these are the thing you guys will get in which header, guys? TCP header here at layer number 4. Is this clear to all of you? Everyone, tell me, guys, yes or no? Right? When your packet will move at layer number 3, layer number 3. So at layer number 3, which header will attach, guys? IPv4 header. Fine. So in IPv4 header, what are the things? I told you version. Second one is, guys, header length. Yes or no? Yes. Third thing, guys, TOS. Right? Types of services, if you guys remember. Right?
Yes.
Now, total length I told you. Right? Then I told you about the identification also. Identification.
Flag.
Next one is, guys, I told you about the flag. Yes or no? Right, na? Everyone. Yes or no? Then I told you about the TTL value also. Yes or no? Yes? Tell me, guys. Then I told you source IP, destination IP. Yes or no? Right, na? So basically, these are the thing you guys will get in which header, guys? In Ethernet header. Yes or no? Everyone, tell me, guys. In which header? Sorry, at which header? IPv4 header. Yes or no? Everyone, tell me.
Yes, sir.
Clear? Now, when your packet will move at layer number 2 will attach which header, guys? Ethernet header. Yes or no? Right? So, what are the content you guys will get in Ethernet header? In Ethernet header, what are the content? First thing, source MAC. Right? Second thing, guys, destination MAC. And the third thing, if you guys remember, I told you about the Ethernet type. Third type. Yes or no? And fourth thing, I told you about the FCS, frame checksum. Right now, everyone. So basically, these are the content you guys will get here. Where, guys? At which header? Which header? Ethernet header. Clear na? Everyone, tell me. Is this clear to all of you? Everyone, tell me. Clear?
Yes, sir.
Okay, cool. Now, see one scenario here. In this scenario, for example, if we have a router 1, router 2 here, PC1 and PC number 2. I hope everyone is aware how we configure the IP address. Fine. So I already told you routers, every interface will be in the same network or different network? In different network, right? For example, this is the fast Ethernet 1x0 and this is 0x0. It means on this router, there are two interfaces. Fine. So this will be in the different network and this will be in the different network. Yes or no? Right? Everyone,
Yes,
tell me, guys. So here we configure which network? 10th network. Here we configure which network? 20 network. And here we configure which network? 30 network. Yes or no? Agree? Tell me. Fine.
Yes, sir.
Here I configure, guys, 10.1. Here I configure 10.10. Here I configure 20.1. Here I configure 20.2. Here I configure 20.10. And here I configure 20.1. Fine. Everyone. Is this clear? Now, for
Yes, sir.
example, if I ping from PC1 to PC number 2, am I able to ping? Answer is no. Right now, I am not able to ping. What is the reason? Reason is because, guys, try to understand. When you ping here from PC number 1, what will be the packet? Source IP will be 10.1. Destination IP will be 20.1. Yes or no? Tell me. Source MAC will be, guys, for example, MAC address is 0A. So source MAC will be 0A and destination MAC, for example, 0B. Then destination MAC will be 0B. Yes or no? Tell me. Agree? Packet reach here on this router. I'm not talking about the ARP and anything. Okay? I'm just telling you the basic thing. For example, packet came here on R1. R1 will forward this packet. Sorry, guys. Sorry. There is one mistake. here we configure there will be the different network, na? Yes or no? That will be guys 30.1 and that will be 30.10. Okay, so I am pinging here 30.10. Is this clear to all of you? So don't be confused. Fine. Now, for example, when this packet will come on router number 1, what router number 1 will do? Router number 1 will check what is the destination IP address. 30.1. It means this IP belongs to which network? 30 network. Yes or no? Yes. So this router, on this router, when you check the routing table, only 2 network are there. 10th network and 20 network. Right now, this router number 1 don't know about the 30 network. Fine. So if this router don't know about the 30 network, then how this router will forward your packet towards here? This is not possible. Yes or no? Agree?
Yes, sir.
Okay. So right now what we are doing, we are configuring one protocol that is called one BGP. Okay. For example, I configure any routing protocol. Here I configure the BGP because BGP is the layer 7 protocol. So I want to show you the TCP header, layer 3 header and layer 2 header all. Okay. So I am configuring one BGP protocol. Is this clear to all of you? Everyone, tell me guys. Yes or no? Agree?
Yes, sir.
Okay, cool. Now,
Yes, sir. Yes, sir. Working, sir.
so I hope everyone is now understand what is our scenario. Clear? Everyone. Okay, cool. Now, I hope this is visible to everyone. Yes? Tell me the same scenario which we discussed here. Clear? On every router, we configure the IP address. Understand? Everyone, tell me guys. On every router, we
Yes, sir.
configure the IP address. Come here on R1. On R1, I am writing so IP interface brief. See, on fast Ethernet 0x0, what we configured? 20.1. Here I configure 20.1 and here I configure 10.10. Clear? Everyone. Come on R2. On R2, I am writing show IP interface brief. See, 20.2 and 30.10. Here I configure 30.10 and here I configure 20.2. Clear, guys? Everyone? Yes or no? Fine? Me. Right now? Now, come on R1. On R1, we are using the BGP. Show IP protocol. See, we already configure here BGP. Clear? So don't focus on the BGP. Just understand here I configure any routing protocol that is belongs to layer number 7. Fine. Now see what I am trying to show. For example, I am capturing this link. I am capturing this link. Okay. Between R1 and R2. Here. Now see, we are on, for example, we are on PC number 1. Okay. And on PC number 1, I am writing ping 30.1.1.0. Where is 30.1? This one. Yes or no? PC number 2. Tell me guys, yes or no? Right now?
Yes, sir.
Right here, ping 30.0.0.1. Timeout, now pingable. So see, now I am able to ping from PC number 1 to PC number 2. That is no problem. Yes or no? Agree? Clear? Tell me guys. Fine?
Yes, sir.
Now, come to the packet capture. Let me stop it. Okay. Now. Are you guys able to see any BGP messages here? Are you guys able to see any BGP messages here? No? Tell me guys, yes or no? No? See, that is the one keep alive messages. That is the BGP message. Yes or no? Everyone, tell me guys. Yes, na? Let me open it.
Yes, sir.
I hope this message is visible to all of you. Clear? Okay. So guys, see here how this packet is encapsulated. That is keep alive message. That is the BGP message. So this works at which layer, guys? Layer number 7. Clear? Tell me guys, yes or no? Right? Now this hand over to layer number 4. That's the reason here. Which message is this? That is called TCP message. This one is guys. Which message? Layer number 4. That is called TCP message. Right now, everyone. That is layer number 3. That is layer number 2. And that is layer number 1. Tell me guys, yes or no? Agree?
Yes, sir.
Yes, na? Okay. Let me open the layer number 4. See here. At layer number 4, I hope everyone is able to see. In layer number 4, what are the things you guys are able to see? First thing, see, source port. Yes or no? Understand? Source port, that is the random port number. Destination port 179 because BGP use the port number 179. So that is the destination port number. Fine, I already told you. Here see, sequence number. Getting my point. Here see, acknowledgement number. Here see, flag. Getting my point, everyone. Here is word, checksum. Here is word, urgent pointer field. Getting my point, everyone. Yes or no? Tell me guys.
Yes, sir.
Right now, so these are the content in which header, guys? TCP header. That is called TCP header. And we will see TCP header at which layer, guys? Layer number 4. At which layer? layer number 4. Clear guys, everyone, yes or no? Now what layer number 4 will do? Layer number 4 will hand over this packet to layer number 3. Fine. So come to the layer number 3. So at layer number 3, what is this? First one is guys, version. What is version? Version is 4. Why? Because we are using IPv4. So that's the reason version is 4. If you are using IPv6, then version will be 6. Sign everyone. Now header length. Header length is 20 bytes. I already told you total size of IPv4 header is 20 byte. Tell me guys, yes or no? Right na?
Yes, sir.
Right na? Okay. That is the total length. Total length means size of header as well as size of data. Fine. That is the identification field. There is a flag. I told you in IPv4 header, how many flags are there? Who can tell me? There are 3 types of flag in IPv4 header. Right now, everyone, I already told you. What are those? MF, DF, and reserve. Yes or no? Tell me, guys. I told you, there are 3 types of flag in IPv4. First one is MF. Tell me, guys. See. MF. MF means more fragment. DF, don't fragment. And reserved. Reserved it 0. Getting my point? Everyone, yes or no? What is the TTL? Time to live. That is the TTL value. That is 255. What is this? Protocol. Protocol field is 6. Why? Because what is the user protocol number? I already told you. Protocol number tells us which protocol you are using at above layer. It means at layer number 4. So at layer number 4, which protocol you are using? TCP, na? Yes or no? At layer number 4, we are using the TCP. So for TCP, protocol number is 6. Are you getting my point, everyone? Yes or no?
Yes, sir.
Tell me right now, if you guys get here 17, it means here you guys will use UDP. Clear?
UDP.
So now there is a source IP address and destination IP address. So guys, these are the things you guys will get at layer number 3. That is called the IPv4 layer header. Fine. What layer number 3 will do? Layer number 3 will hand over this packet to layer number 2. So at layer number 2, see, destination MAC, source MAC. Yes or no? And that is the type. What is type? So what is the type? 0x0800. Why? Because you are using the IPv4 address. Fine. So here you guys will get only 2 values. Here you guys will get only 2 values. Fine. If you are getting 0x0800, it means you are using IPv4. If you are getting 0x86DD, it means you are using the IPv6. And if you guys are getting here 0x0806, it means you are using the ARP. Fine. So right now we are using the IPv4. So that's the reason 0x0800. So that is all about guys layer number 2. What layer number 2 will do? Layer number 2 will hand over this packet to layer number 1. So that's the reason. See, here you guys are getting what? Bits, na? Everyone. Yes or no? Right? So your all data will convert into the bits. Getting my point? Everyone. Yes or no? Tell me. Understand? So I hope now you guys understand very well OSI model theoretically as well as practically. How actually whenever we configure any types of layer 7 protocol, how actually our packet will encapsulate and how our packet will flow on the network. Getting my point? Everyone, tell me yes or no.